little bit.
Okay, so what's true about the value of y for any time you have an x-intercept?
0.
Y equals 0. Hold on, my screen is frozen. Okay, so anytime you have an x-intercept, that's along the x-axis, and that means you're going to have a number for x and 0 for y. What about the value of x for all y-intercepts?
0.
Okay, so for a y-intercept, you're going to have 0 for x, and then a number for y. Okay, cool. So now what I want you guys to do is I want you to find the y-intercept of this equation. Y equals 2 times x squared plus 5x minus 1. All right, so I'm going to give you guys like a minute or two to find this y-intercept. Now remember, when you're finding a y-intercept, and this is true for any equation, not just quadratics, if you're looking for a y-intercept, all you have to do is plug 0 in for x. So if I were to plug 0 in for x, I would get 0 squared, which is 0, times 2 is still 0, plus 5 times 0, also still 0. So negative 12. So my y-intercept is negative 12. How many of you guys got that right? Okay, fantastic. Okay, so when I have an x-intercept, we just talked about this. What is the x value for an x-intercept? The x value is going to be a number, so x. And what is the y value? 0. So when I have an x-intercept, it's a point along the x-axis, and it's always going to be whatever number it is for x, and then 0 for y. What about for a y-intercept? What is the x for the y-intercept?
0.
That's 0. And then what is the y for the y-intercept? It depends on wherever it is, so it would be whatever the y value is of that point. So when I have x-intercepts and y-intercepts, I've got zeros. Make sense? Okay, cool. Okay, so calculate the y-intercept of y equals 2x squared plus 5x minus 12. This is what you guys just did. So I'm finding the y-intercept, so that means I'm going to put 0 in for x. So if I put 0 in for x, I would have 2 times 0 squared plus 5 times 0 minus 12. So that's 0 and 0 minus 12. So my y-intercept is negative 12. Now remember, anytime I am asking you guys to tell me a point, I want you to give it to me as an ordered pair. So x-intercept, y-intercept, vertex, all of those things you should write down as an ordered pair. So the y-intercept is going to be the point 0, comma, negative 12. So there's my y-intercept. Okay, what if I said, find me the x-intercepts of this equation? I plug 0 in for y. Okay, so I've got 0 equals 2x squared plus 5x minus 12. This one doesn't seem quite so straightforward as the y-intercept was. How do I solve this equation for x? Add 12 to both sides. Okay, so that would give me 12 equals 2x squared plus 5x. I got x's in 2 spots. Do you guys know how to solve an equation like that? No, not yet. So right now, even though we plugged 0 in for y, right now we're at a spot where we can't quite solve it yet.
Yeah.
That's a great idea. Well, let's find out what we could do.
Why you do that?
Okay, let's play guess a number. I'm doing 5 times a number and I get 0. What's my number?
0.
Okay, cool. Now I'm doing a number times negative 7.
0.
It's 0? Okay. Now I am doing 1/4 times a number and I get 0.
0.
It's still 0, huh? Okay. What if I do 5 times 6 minus 4 times 3/4 plus 6 times a number and it equals 0? What do I get?
Oh, so X equals 0.
0. Not quite. What if I do pi times a number and I get 0? What's my number? 0. So does it matter what I'm multiplying if my answer is 0? I don't know. That's some crazy Greek symbol there. I don't know exactly what it is, but when I multiply it by my number and I get 0, what's my number?
0.
0. Okay, now what if I had something that looked like this? I have something in parentheses times another thing in parentheses and it equals 0. What does one of those parentheses have to be? 0, right? And then it doesn't matter whatever's in here. It could be like x plus 7. It doesn't matter as long as one of the parentheses is 0. What if I had 3 sets of parentheses multiplying and they equal 0? Either this one is going to be 0, or that one's going to be 0, or that one's going to be 0. In this one, could this parenthesis have been 0? Okay, so this is leading us to what we call the zero product property. The zero product property tells you if I have two things that are multiplying, because product means multiply, and the product is 0, what must one of those things be? 0. Okay, so does this look familiar to you guys in all we've been doing with our quadratics? This looks a whole lot like factored form, right? Factored form was our product. Do you remember we wrote the area as a sum and we wrote the area as a product? And factored form was our product form, right? So if I have it in factored form and it equals 0, that means I can say either all of the stuff inside this parenthesis equals 0, or all of the stuff inside this parenthesis equals 0.
Or there's both.
Or maybe they both equal 0. That could be true too. Okay, so let's go back to our notes. If it's in standard form, I can't do much with it. But if I can change it to factored form and it equals 0, then I can do something with it. So let's factor this. Let's get this to factored form. Where do I put my 2x squared? Bottom left. Okay, so 2x squared. Where do I put my 5x? Bottom of the diamond. That's where my x terms go. Where do I put negative 12? Top right. It has to go on the diagonal with my 2x squared. And then what goes on the top of my diamond? Negative 24x squared. So I multiply these two and I get the top. So negative 24x squared. Since this is a negative, that means that I'm going to have my sides. One is going to be a positive and one is going to be a negative. So I'm going to write that in there, positive and negative. And then when I add them together, I'm really doing a positive minus a number. So I'm finding the difference. Okay, so I'm going to go through my factors of 24 and see which ones have a difference of 5. Do 1 and 24? No, that's 23 apart. How about 2 and 12? No. What about 3 and 8? Yes, so those are the numbers that I want. Which one should I do positive? 8, because it's a positive 5, so I want my bigger number to be positive. So 8x minus 3x. That gives me 5x when I add them together. Then I'm going to move those over to here. And again, it does not matter which one you put in which spot. You'll still get the same answer out. Okay, if I'm looking at this column, 2x squared and 8x, what's the greatest common factor? 2. So I'm going to put 2x down here. And then if this is a 2x, this one's got to be an x. If this is an x and it multiplies to negative 3x, then what has to go down here? Negative 3, because negative 3 times x is negative 3x. If this is a 2x and it multiplies to 8x, what goes here? 4. Now, your final step is to double check to make sure you did it right. 4 times negative 3, that does give me negative 12, so I know I did it right. Okay, that's just the part to get us to the point where we can solve. So that was just changing it to factored form. So now instead of writing it in standard form, I can write it in factored form. 0 equals x plus 4 times 2x minus 3. Okay, now the zero product property says if I have two things that are multiplying, my two parentheses are multiplying, and they equal 0, then one of the two parentheses has to be 0. So that means maybe x plus 4 is 0. So I'm going to write this equation, x plus 4 equals 0. Now I can solve this equation for x, right? Subtract 4 from both sides, and I get x equals negative 4. All right, so there's one of my answers. Maybe this equation equals 0. 2x minus 3 might be the one that equals 0. Solve this equation, I need to add 3 to both sides. That gives me 2x equals 3, and then divide both sides by 2. And that gives me x equals 3/2, or 1.5. Those are my two x-intercepts. So to find your x-intercepts, you're still going to plug 0 in for y, but you have to have it in factored form before you can actually find the x's. So I would say my x-intercepts are the points -4, 0, and 1.5, 0. Those are my x-intercepts. It's way easier to find the y-intercepts, right? Plug it in 0 and get your y's. But the steps for finding the x-intercepts, none of them are new. It's just putting them together in a new way. So changing it to factored form, and then solving each parenthesis, saying, what if this parenthesis was the one that equals 0? And getting that x. And then what if this parenthesis was the one that equals 0? And getting that x. Okay, so let's take a couple more notes here. In math, we call the x-intercepts lots of different words, and they all just mean the same thing. So if you see roots, they're talking about the x-intercepts. If you see zeros, they're talking about the x-intercepts. So anytime you see any of those words, they're just talking about the x-intercepts. So if anything says, find the roots of this equation, you're just going to find the x-intercepts. Or if it says, find the zeros of this equation, you're going to find the x-intercepts. Does that kind of make sense? Okay. And then let's write down what the zero product property is so that you have that in your notes as well. So the zero product property tells us that if you multiply two factors, so it could be numbers, it could be a number and a variable, it could be sets of parentheses like we have, and the product, remember product means we're multiplying, is 0, then one of the factors, one of the things that you're multiplying must be 0. And we use the zero product property and an equation in factored form to figure out the x-intercept.